Hi, this is Miss Eric, and I'm going to go over some more geometry questions. These specifically relate to plotting graphs. So this is from the January 2015 test, question number 36. It wants us to graph y is less than x and x is greater than 5. So because this is a y, the easiest way to do this is to go to my calculator. So anytime I want to graph, please go to the calculator. So I'm going to hit y equals, and it wants y is less than x. So we already have our y. I'm just going to hit x. And because it says less than, I need to hit my arrows over, and I'm going to hit it till the triangle is on the bottom. So I hit enter once to get bold. That means y is greater than with the triangle on the top. And I want y is less than. So I'm going to get my triangle on the bottom. Now I like to go right to the table. So some people like to hit graph first. So we can hit graph first just to see what we're looking at. And now I'm going to go right to my table and see the points. Okay, we see all the numbers just match perfectly. So because this is y is less than x versus y is less than or equal to x, I know this line is going to be dotted. And I know this line is going to be dotted. So right away, I am just going to dot my line, going right up. And you probably should use a straight edge. I'm not. Then we're going to label it, because there's two graphs, we have to label it. Now the next one, it wants x values that are greater than 5, but not equal to. So I know it's going to be dotted again. So I need x value, so this is the x-axis, where x is greater than 5. 1, 2, 3, 4, 5. So now I need to dot my line here. And it might be hard to see, but we have to do our graphs in pencils, right? And it wants, ooh, I didn't shade here. Why didn't you stop me? Here's my shading here. Now it wants x is greater than 5, so I need to shade this way as well, all the way up. And then it says state the coordinates of a point in the solution set. It's anywhere from here. I'm going to use my pen just to show you. So this was my dotted y equals x line. I'm sorry, y is less than x. This is my dotted x is greater than 5. I need a point that's in this area right here. So any point will do. You know what? I'm just going to say 9, 0 because it's easy enough. 9, 0. Okay? Remember, all I did is because there is a y, plugged it right into the y equals of the calculator. Okay, let's pop over to the next question. Okay, this says on the set of axes below, solve the following system of inequalities graphically. In order for me to use it in my calculator, I have to get y by itself. So I'm going to start with this one over here. Y plus 3 is less than 2x. I need to get y by itself, so I'm going to get rid of the 3. The opposite of adding 3 is subtracting 3. So I know y is less than 2x minus 3. So I'm going to go back to my calculator. Y equals, hit clear to clear this out, 2x minus 3. I want y is less than that. So I'm going to go to my arrows. And keep doing this until I get the triangle on the bottom. Then I'm going to hit second table. And here I can see my points. Okay, -3, -9 is the first one I can plot. So we have our -3, 1, 2, 3, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, this one is going to be dotted. And now I know in my head I can go up to over 1. So I'm going to go up to over 1, up to over 1, to over 1. Okay. This definitely would be a lot easier if I used a straight edge. But use your imagination, and on the test, you do it. Now I'm going to write my equation. And now I'm going to hit the graph button to see which way I shade it. Okay, on the bottom. Now we have this equation. I have to get the y by itself, so I'm going to divide by -2. Now, here's the trick. because I'm dividing by a negative, anytime we divide or multiply by a negative and there's an inequality, we flip the sign. So this is really y is greater than or equal to negative 3x, 6 divided by negative 2, negative 3x. Negative 10 divided by negative 2 is positive 5. Now I can type it right back in my calculator. Negative 3x plus 5. This is a solid line because of the equal, greater than or equal to. I'm going to hit my arrows over, and I want the triangle on the top because it's greater than. So it's going to be this one. I can hit graph to see what it looks like. And I can hit second graph again to get the table. So negative 1/8 is my first one I can point. And then I know I'm going down 3 and over 1. And I would use a straight edge. Don't copy me, please. And it wants to have the values that are greater, so I can hit graph to see that I'm shading up. Now remember, this line was solid because it was the equal sign. I have to label it. And once the points of the one in the solution set, I'll pick my good old trusty 8, 0. And that's good enough. Not bad for 4 points, huh? Okay, here's another one. This is another 4-pointer. Instead of axes below, solve the following system of equations graphically. Label the solution set S. Okay? Remember, we need to get y by itself. Ooh, it would help if I wrote it correctly and didn't do it in my head, wouldn't it? Got to move this over here, so I'm going to subtract 2x. This cancels. I'm left with 3y is less than negative 2x minus 3. I'm going to divide each one of these things by 3. Y is less than negative 2/3 times x minus 3 divided by 3 is 1. If I go over here, get this over here after the subtracting is adding. Y is greater than or equal to 4x plus 2. Okay, there we go. Time to graph. Alright, because this is equal to, I know this is going to be solid. Because this is just less than without the equal to, I know this is going to be dotted. I'm going to go to y equals, clear this out. I'll type this one in first, 4x plus 2. It wants y's that's greater than, so my triangle's on the top. Because we want to have more money, we want to be on top of the world. Okay. Hit graph. And there we go. I'm going to hit table to get the points. Negative 310 is the first point. Negative 310. This one's going to be a solid line. I'm going to go up 4 over 1. If you know slope. Otherwise, you can just look right at the graph. I'm sorry, the table. Look at me using my straight edge. Pretend I am. Y is greater than or equal to 4x plus 2. I know from when I did that, I know shaded. It's these values here. This one's going to be dotted. I'm going to go back to my y equals. I need to plot in, actually let me make this just a tad darker. I need to clear this. I have to put the negative 2/3 in parentheses though. So I'm going to have parentheses, negative 2 divided by 3, parentheses. Now I can have my x, then my minus 1. I'm going to go over and it wants y values that are less than. So I'm going to hit enter till the triangle's on the bottom or the lower triangle. Hit graph so I can kind of get an idea of what I'm graphing. Hit second table to get my points. Let's see. Negative 9, 5 is my first good one. So here's negative 9 up 5. Now this one I know when I do it will end up being dotted. Okay. It wants me to go down 3 and over 2. No, what am I doing? Down 2 over 3. Clearly I'm not awake right now. That's why we do this in pencil. My bad. Down 2 over 3. Down 2 over 3. down to over 3. Okay, now we're going to dot this out using our straight edge that is invisible. Label it. Shade it. And then it wants us to label the solution set S, so where these cross. Gets the S. There's another 4-pointer. Here's another 4-pointer. Lots of 4-pointers. I guess we really should know how to do this, huh? Okay, this one's really nice for us. It already put it in y equals form. So I'm going to go to my y equals, hit clear, type this in. Negative x squared minus 2x plus 3. I'm going to hit graph because I want to teach you something. If it ever asks you to find the roots, which it did in the June 2015 test, the roots are where it crosses the x-axis or where y equals 0. Now this question doesn't ask us for the roots, but if it did ask us for the roots for this graph, it would be -3 and 1. Okay? Well, let's just plot these babies out. So we know -4, 5 is our first easy plot. -4, 5. I'm sorry, -4, -5. We know this one's going to be 12, which will be down here. -3, 0. -2, +3. -1, +4. And, oh, 0, 3. Goes right back down already. 0, 3. Keep using my arrows. 1, 0. 2, -5. And then we know this one would be down here. So now it's equal, so it's solid line. Because there's two graphs, I have to label it. Just as a side note, because this is negative, we know it's concave down, and as a side note, this is going to be a max. And that's also the vertex or the turning point. All right, but anyway, let's do this one. We got to get y by itself, so I'm just going to subtract 1. Y equals -2x minus 1. Get back to my calculator, hit y equals, hit clear, -2x minus 1. I can graph it to see what it looks like, but I like hitting the table, so I'm going to go to the table, second graph, there we go. Let's see where our pretty points are, -5, 9. 3, 4, 5, 9. -4, 7. And these just go down by 2. Okay, look at my very beautiful imaginary straight edge. And see how it crosses here and here. The two graphs cross if I did a better job. So state all the solutions of it. Well, the solution would be -2, -2, +3, and +2, 1, 2, 3, 4, 5. 5. Okay, so those would be the solutions of the systems of equations. -2, 3, 2, 5. Hey, we just finished. Congratulations. That's graphing systems of equations in our geometry for the integrated algebra exam. Great job.